This is the continuation of the notes from section 2.2 that I started yesterday in class. So let's practice how to graph a circle given a center and a radius. You're going to have to do this on Alex as well. So what we first start doing, and I'm just going to count by ones here, is we plot the point for the center. So I'm plotting -1, 2. Now that I have a radius of 3, I just count 3 in several different directions here. I'm going to count 3 to the right, 3 up, 3 to the left, and then 3 down. But on Alex, I believe you have a circle feature, so all you have to do is plot one of the points as you count to the right or to the left, up or down. I have a circle feature on here as well. And it should look something like that. All right, for our next example, again, pause the video if you need time to copy this down. But we're going to write the standard form of an equation of a circle with endpoints of the diameter. So they're giving us the edges of the circle that the diameter intersects here. So the endpoints of the diameter at -1, 0, and 3, 4. So if we needed to, we could make just a quick sketch of a coordinate plane and just plot the points roughly. Sometimes a nice picture can go a long way here. So if we're at -1, 0, that would be right here. And then 3, 4. So this would be the diameter of our circle, which means our circle could look like this. No, it's not the best looking circle, but it gets the point across. So what do we need? Well, we need to figure out where the center of the circle is, and we need the radius. Those are the only two pieces of information we need in order to write an equation of a circle. So I know my center has to be, the diameter goes through the center of the circle. So what did we kind of go over in section 2.1 that's going to help us with this? If you're thinking midpoint, you're correct, because the center is right in the middle of the diameter. So we want to find the midpoint. So we'll say first, find the midpoint, just abbreviated here, of the line segment with endpoints at -1, 0, and 3, 4. All right, so midpoint, if you remember, we're going to add our x values together. So -1 plus 3 divide by 2. We add our y's together, so 0, 4, 0 plus 4 rather, over 2. So this will give us a midpoint. -1 plus 3 is 2 over 2. Then we'll get 4 over 2. So we get a midpoint of 1, 2. And that's our center. So we'd say the center is at 1, 2. Now we need the radius. So it wasn't too bad here. This is at the point 1, 2. So now to find the length of the radius, which would be right here, we need the distance. So we're going to use the distance formula. But I'm going to go from 1, 2 over here to 3, 4. You could go from -1, 0 to 1, 2, but we don't have to find the whole length of the diameter here. We just find the radius by going from the midpoint or the center to one of the endpoints here. So we're going to find the distance. And again, we're going from 1, 2 to 3, 4. So the distance is the square root. I'm going to subtract my x value. So in this case, I'm going to go 3 minus 1, that quantity squared, plus 4 minus 2, that quantity squared. So that's going to give me 2 squared plus another 2 squared. And then this will give me the square root of 4 plus 4, which is the square root of 8. Now I don't have to simplify this because I'm going to use this. I need to write out the equation of a circle. And if you recall what we do with the radius, we square it. So there's no need to try to simplify this. So then our equation is going to be, here's our center, x minus h, I'll fill this in the next step. I just want to write it out generally first, times or plus the quantity of y minus k squared is going to equal r squared. So my h is 1, so we're going to have x minus 1 squared. My k is 2, so we'll have y minus 2 squared is going to equal the square root of 8 squared, which just becomes 8. So we get the quantity x minus 1 squared plus the quantity y minus 2 squared is going to equal 8. And there's our our answer. There's our equation. All right, next we're going to take a look at, we know the standard form of the equation of a circle. Here is the general form where we don't see any quantities, we don't see any parentheses here. So the general form of the equation of a circle is x squared plus y squared plus ax plus by plus c equals 0. Now for this to be a circle, we definitely need to see an x squared term and a y squared term. The x, y, and c may be there, they may not be there. So in this third example, we're going to write the following equation. Right now it's given to us in standard form. We just need to write it in general form. And how we're going to do this is just expand, which means we're just going to square the quantity x minus 1, and then we're going to square the quantity y minus 2. And again, at any point, pause the video to copy this down. Okay, so when we expand x minus 1, that quantity, when we square it, becomes this. Likewise for the y minus 2, then we're going to use the FOIL method. So we're going to get x squared minus an x on the outside minus x on the inside, and then a plus 1 last. Over here we're going to get y squared first. We'll get a minus 2y on the outside minus 2y on the inside, and then plus 4 last. So I'm going to put my x and y squared first because that comes first, x squared plus y squared. Then I want to combine my x terms here, so negative x minus an x is going to become a negative 2x. Then I want to combine my y, so I have a negative 2y minus a 2y, so it's a minus 4y. Then I want to add the numbers here, so I get a 1 plus 4, so we get a plus 5 equals 8. And because it's equal to 0, I just want to move the 8 over. I want to subtract 8. So this now becomes x squared plus y squared minus 2x minus 4y minus 3 equals 0. And that is the general form from standard form. In our next few examples, now we're going to go in reverse. It's a little more to it, but we're going to be given an equation of a circle in general form. We have to write it in standard form. So what's nice about this is it's going to give us practice from what we saw in an earlier section. We need to complete the square. So go ahead and copy this example down. All right, so what we want to start with is grouping our x terms together. So I want to keep the x squared plus the 10x together, and I want to put the y's together, plus y squared minus 6y, and then I want to move the constant to the other side, so it becomes a negative 25 over there. So now I'm going to create perfect square trinomials out of this. So in parentheses, I'm going to put x squared plus 10x, and I'm going to leave a little bit of space and end the parenthesis, plus the same thing here, y squared minus 6y, leave a little bit of room, and then put the equals negative 25 on the other side. So I'm going to complete the square here. Remember, this is where we're going to take half of the 10, which is 5, and then square it. So half of the 10 is 5. 5 squared is 25, and that's what I add here. And since I added it to this side, I need to add it to the right side. Next, I'm going to take half of the 6. Remember, the signs doesn't matter because we're going to add anyway. So half of 6 is 3. 3 squared is 9. So I'm going to add 9 to both sides. So now I can write this quantity, since it's a perfect square trinomial, that'll turn into the quantity of x plus 5 squared. All you have to do is factor that into two binomials, and you'll see that it comes out to x plus 5 squared. Next, since there's a minus sign, I do y minus 3 squared. Here the 25s together give us 0, so this is just 9. And then if we were asked to identify the center and the radius, the center would be negative 5, 3, and the radius is a square root of 9, which would be 3. So let's try another example like this. If you want to pause the video and give it a try on your own, go ahead and do so. If not, follow along. Again, we want to start grouping our x terms together, so x squared minus 8x, and we have a plus y squared plus 2y. We'll move the 8 to the other side. And we'll go ahead and start to complete the square here. Again, just leave a little bit of space here, and with the y's as well. So we have to figure out what to add to each side. So half of 8 is 4. 4 squared is 16, so I'm adding a 16 to both sides. Half of 2 is 1. 1 squared is 1, so I'm going to add a 1 to both sides. So now this quantity will factor into x minus 4 squared. Next we'll get a y plus 1 squared. This will add up to 25 over here. So here our center would be 4, negative 1, and our radius is 5, square root of 25. All right, one more example to try. We're going to first write this in standard form, and then we'll start to see what it means here, identify the solution set. So again, if you wish to give this a try on your own, pause the video. Now remember, the first step is to get all the x's together, but if you notice there's only one x squared term, there's no other just x term. So pretty much the way it's written right now is going to be good enough. We just need to move the 49 to the other side. So what I'm going to go ahead and do is just put the y's in their parentheses with leaving a little bit of space. We'll move the 49 to the other side. So there's nothing to add on. There's nothing to complete the square here for the x squared because it has no linear x term here. So half of 14 is 7. 7 squared is 49. So we're going to add 49 to both sides. So now this becomes x squared, and we'll factor this into a y minus 7, minus because there's a minus sign here, 7 because it's half of 14, or it's the square root of 49. But notice what happens over here. We get a 0. So let's identify the center. The center, because there's nothing else here, the h is 0, and then k would be 7, but our radius is 0. So is that truly a circle if it has no radius? Which means if we were to graph this, we would be at 0, 7, so that would be up here. We just have a point. We don't go out any. So it's not really a circle, it's just a point. So this tells us our solution set is just x equals 0 and y equals 7. So we can write this, because that's the only point technically on this, if you want to call it a circle. Other circles have an infinite number of points, but this is just one point, so that's why we can say we have a solution set. All right, so that concludes the examples for section 2.2.